session MCSL 228, which is basically the AI. Good morning, Sylvester. Good morning. So, good morning, everyone. And if you are uh, if you are my, if you are getting my voice clearly, so you may continue. Or if anyone having any issue in the so this is the seventh session. This is the seventh session. Here we have to discuss about the best first search, and this is the seventh session. We have discussed about the best search technique, and before this session, we have discussed about the breadth first search. We have discussed about the depth first search, and we also have discussed about the iterative deepening depth first search. This these three techniques we already discussed in the previous sessions, and we also have seen the code, the Python code, how to write the program for these searching techniques. We also have seen the difference and the comparison among these searching techniques, where how these searching techniques basically work and how they help in the game playing, etc. We have seen their implementation, we have seen their merits and the demerits. Now today we have to discuss about the best first search, which is also a kind of searching technique, but it is somehow different from the breadth first search, depth first search, and IDDFS searching technique. So before going to before going to show you the particular code of the BFS, let me first tell you some basic about the best first search. And by the graph, let me show you how the best first search is uh, how the best first search basically works, and how it is different from the BFS, DFS, and the IDDFS technique. So let me start here. So the best first search is a kind of informed search technique. We have a two kind of the searching technique: informed search and the uninformed search. In the case of the uninformed search, we only have a goal node, and we need to traverse the tree either breadth wise or the depth wise in order to find a existence of goal node. So, so in the case of the breadth first search, depth first search, or IDDFS, these are the uninformed searching technique, where we have seen that we have given a graph, we have given a goal node, and we need to find out an existence of goal node in the tree. The goal node may be present or may not be present, but we need to find out the existence of goal node in the tree. We have seen the two major techniques, the BFS and the DFS, the breadth first search technique and the depth first search technique, the kind of the uninformed search. Where in the case of the breadth first search technique, we are visiting each and every node at a particular level breadth wise. So at a particular level, at a particular depth of the tree or the level of the tree, we visit all the nodes available to the particular level. Whereas in the case of the DFS, depth first search technique, we are not visiting all the nodes at the particular level. We visit all the nodes depth wise. The leftmost node, the depth wise, is going to be visited in the case of the DFS. So we are going to the innermost depth of the tree, and then and visiting all the left nodes of this one, and then we backtrack, and then we visit the right nodes, and simultaneously we proceed. So we have seen the difference. So this is the basic difference between the BFS and the DFS technique. In the BFS and the DFS technique, we continuously visit the nodes, and we make we the present is available or not. Very simple. In the case of the iterative deepening depth first search, this take the advantage of BFS and the DFS. So BFS and DFS having their own merits, and IDDFS basically take the merit of both of the BFS and the DFS, and then the IDDFS technique basically works. And the IDDFS technique basically combining the properties of both of this one, and it visit all the nodes at the particular level, at the particular depth level, as per the uh, DFS technique. So we already have seen all these things. So this was the context of that one. So these are the uninformed source where we have given the goal nodes, and we need to traverse the entire tree in order to find the node. We don't have given any kind of other information which may help me, which may well help us to find the node. So that is the uninformed search. Whereas BFS, based first search, is a kind of informed search, a kind of heuristic algorithm where we give a some heuristic value, and we basically the best first search basically helps us to find the existence of the node and so BFS is a kind of informed search where we are given some prior information given, and these prior information generally known as heuristic values, and with the help of this heuristic values we may reach to the goal node. So that is the BFS technique. So let me draw a graph, and then let me show you how these graphs basically help us to reach to the goal node. So let me create a graph. So these are the graphs. Let me create the entire graph, and then show you how the BFS technique basically proceed and find out the goal node. So let me create a graph very quickly. So this is a graph, basically a binary tree. So the graph may having a circular, graph may having a circle, but yeah. So let me first create. Then I talk to. Let me create the nodes. Let me create a some tree. You may have some better idea about this one. So this is a graph. Here we have a various nodes. So this is a graph we have given. Let me label it. Let me give it the name to each and every one. So we may have some further idea of this one. This is the A. This is your B. This is your C. This is your D. The node name is D, F, G, just a minute. So H, then this is your node I, this is your node, just a minute. So this is first search technique, and we so this tree having all the nodes are labeled B, C, D, E, F, G, H, I, J, K. Just again, here about this search technique. The BFS technique. From search given for search, for search, for search, we any information. We just have given start. We don't given any extra information which may help us to reach to the goal. So that is the scenario with the other uninformed search technique. We have informed some extra bit of information will help us to reach to the. So let us come to the graph, and this is our goal. This is our goal. Our goal, and we have to reach to this goal node starting from the starting node. So here we have given some weight. Here we have given some kind of the cost in order to reach from the A to the B. So we some cost we may have given. We may have given some cost. That is the because this is a kind of technique. So some extra bit of information we may have given. So a cost we may have given. So in order to start the journey from node A to the node B, it required 5 to reach A to the B. Similarly, B to the D, we have some given we this cost and how we have to mention about how to calculate the cost we given is the beyond the scope. So just given some cost, and based on the cost, you have to some cost we have given with each and every edge. The graph here with path from the A to the K. So our node is your A and the goal node is your K. A goal node is a the so so here so in order to reach from the A to K, so this is the heuristic value we may have given. We have to it with straight line distance. Straight straight line distance we need to calculate. This is being calculated as per the Euclidean distance formula. Euclidean distance formula. I'm not to discuss Euclidean distance here. We're just assuming that you may idea about Euclidean distance. So straight line distance it will be calculated. Let me put up the value. So in order to reach from the A to K, we required a 10 cost is reaching from the A to goal node K is 10. Similarly, from B, it is it is calculated. From the C reach to the goal node, it is this value you need to calculate by the straight line formula. So just let me write down so that you may easily understand how to find the how to find a best path from K required only 3. Similarly, G to K unit to K uh, is 3 now from to K it is 1 and from G it to it is a given, and now we have to find out the path. This is given these kind of the information. We have given this kind of the information, and now we have the best path. Uh, my device, I don't know whether my network. Muhammad Abdullah, you may please log out and log in once again. You may please log out and log in once again. It may help. Uh, if or screen, then I may log out and the log in. Okay, so let the Abdullah log in once again, and then we will proceed. We might solve the issue. Let 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 it get for a few seconds, probably. Yeah, join. So now let me know the Abdullah. Muhammad Abdul, are you getting the screen? Now, how the BFS, the best first search technique, basically allow us to find out the best path from the node A to the goal node K. So for that, let me stop this presentation here and let me go to the algorithm. Let me show you the algorithm so that you may have some better idea about this one. So just I'm showing the algorithm very quickly. So it will help you to find out the best path. So so as you can see here that this is the algorithm. This is the algorithm for the BFS. So what we have to do, we have to take a open priority queue. We have to take a data structure open and take a priority queue data structure. We have to take a priority queue data structure and let it's named as a open priority queue, and it contain a initial state, the initial node, the node from which we start. So open, if the open priority queue is empty, means there is no nodes available in the tree, then we may simply return the failure. This is the simple hypothesis. However, always you may have given some kind of the tree. But suppose that you don't have given any kind of a tree, and someone told you to start the activity. So how you may terminate the algorithm. That's why this is the common line. So if the open priority queue doesn't have any node, it is a blank. Means that there is no there is there is no group. Else what we have to do, the first node wherever so priority queue is a kind of data, probably studied about the queue data structure in the data structure class. So queue is being formed by the help of linked list. So priority queue means those kind of the node which holding the highest priority value. Uh, Priority queue is a queue. In order to implement a queue, we are taking the linked list. So So similarly, the priority similarly, so we are forming a queue, and queue holding queue was the either the LIFO last in first out methods or first in first out method. So uh, typically, whenever we are taking a queue data structure, so it works as per first in first out technique. So, so a queue, we are taking a queue. So the first node will enter into the queue, and the last node will come out from the queue. Just let me show you by some. So this is a queue. This is a queue where the nodes will enter, where the nodes will enter by this side, and the value will the node will be coming from this side. So this is a simple nodes is going to be insert here in the fashion of first in, and here it is getting out from as a first out. Just so the, so this is the queue, and once the queue holding the nodes, the highest priority nodes, and we have to rearrange the nodes in the priority level. Then this is known as the priority queue. So here, so let's come to the so here we have so we are creating a priority queue. So priority queue, and the name of this priority queue we are keeping as a open. So open is a kind of priority queue. Priority queue, there is a priority queue, and named it as a open. So if the open is empty, if there is no nodes available in the queue, it means that either we have reached to the goal node, or there is no such kind of nodes available in the graph. So in both of the case, we simply return the failure. Otherwise, else we need to visit the nodes one by one. So we open the so we will take whatever the first node available in the queue, priority queue, what is the topmost node in the open queue, that will be taken, and this will be transferred to the node. Now, if this transfer the first node from the open queue to the node. So whatever the first node in the open queue, that is being transferred into the NODE, and if on the path from the initial node to the node. So it might be possible that the first it may good. So if from the initial node and put the newly generated node in the open according to their F value node value. So state now whatever the node that was transferred from the open queue, we have to take the successor node that having the very less cost, and we have to explore the tree with. So this is a simple algorithm. Now let me stop this and let me go back to the graph, so that by now you may understand that how basically the IVFS depth first search technique basically work. So let me start here. So we start given some heuristic value we may have given, and some kind of the straight line value we may have. So these kind of the things we have given, and now we have to visit from the node A. So let us start with the node A. So so at a first instance, we set the node A as per the algorithm. So in the open queue, the initial node is being placed. So in the open queue, a node A has been placed, and now we make a comparison that whether my this so this is the open A, so the A was placed in the open queue. Now proceeding with the next line of the algorithm, now we compare whether whatever the node is in the open queue, if it is in the open queue, we will terminate the algorithm. Else we have to explore. We have to successor with the f value. This is the f value we have given. So we have to explore the explore with the f value. So let us start here. For node A, we may out what is the successor node of node A. So we can see here that we have node B and node C is a successor node. So we simply draw node B, is successor node of node B, and we have f value taken from this is and in order to reach the B, tells that the goal node require a cost. Interesting that B was not looking so. Let me write down here. B and this is your C. If value tells us that B tells us node B tells us that in order to reach to the goal node, B tells us that I required there is a cost 7. B tells us that you may reach to the goal node K by a cost of 7. So this 7, the cost 7, we should write here. So let me write the 7 cost here that it may show you just cost 7. So from B to the K, it required 7 cost. From the C to the K, it required cost 5. So there is a cost 5. So the C having the knowledge about the key by the straight line formula. C having the knowledge that from the C, in order to reach to the goal node K, from C it required 5, whereas from the B it required 7. So now, so these are the successor nodes we have taken. Now, among these successor node, we start the journey with the node that having the lowest cost. So C having the lowest cost. So we explore the C because we have not reached to the node. So we explore the C, and now the C. So you can see here C is connected with the F only. So we have only single F. If we have multiple nodes here, so you may take the multiple nodes, and then we have to look at what is the straight line cost in order to reach from this node to the goal node. So it's here, it is showing that a cost of 3 required in order to reach from the F to the goal node K. It required a cost 3, and now still F is not a goal node, so we need to explore the tree. So from the F, we have only one node connected with the F, that is a I, and from the I to the K, from the I to the K, it required a cost 3. So we let us put the cost 3 here, and as this I is not a goal node, so we explore the I, and I is only connected with the goal node K, the node K. So let me put here, and so I to K, and K is the goal node. Sorry, K is the goal node. K is the goal node. So K to G, it is a 0. Cost is 0. It is not a G, it is a K. So by this way, we have exploring, reaching the one particular node, we explore the sub we explore all the connection of the particular sub node, and we proceed until unless we are not reaching the goal. And the total cost we have found visit the entire 5 plus 3 plus 3, 5 plus 3 8 plus 3 11, so total cost is 11. So we have found a path. So from we have to go from the A to C, then from the C to F to H, F to I, and I to K. If you count here, so you may see that the cost we have calculated and the cost showing into the graph will become the same. So here 2 plus 3 5 plus 4 9 plus 2 11. The same will be. So this is a concept of best first search. Now let me continue the first search. So this is the basic concept of the first search, and it is not discussed in this particular session. In this particular session, I only need to discuss the code of the BFS. I supposed to discuss only the code, Python code of the best first search, but it is my duty to code explaining the Python code so that you have some idea, the basic idea, the basic knowledge about the concept, and then it will become a explode the Python code. So I have shown you. Otherwise, it was your duty to go through the basic concept from the MCS to to 4 paper, that was the AI and the ML. Uh, yes, do you have any question, or can you please mute yourself? Okay, thank you. Yes, who has raised the hand? Please put your question. Either you may unmute yourself and tell me the tell me your question, or you may type your question in the chat box. Okay, no, so it was down. Okay, so let me continue with the code. So now the screen is visual, the code screen is visual. So what we have to do, we have to first create the graph. So let me create the graph. So a graph I already has created. Whatever the graph I have shown you previously, the graph we have discussed that is being created by this data structure, graph data structure in the Python code. How to create the graph we already have seen in the previous sessions. So by this way you may create the graph, where you can see that the node A is connected with the node B with the cost 5, node C with the cost 2, node B is connected with the node D with the cost 4, node E with the cost 9, and so on. So we have created a graph, and then we are here defining the heuristic value. The heuristic value we are assigning the straight line being calculated by the straight line value. Moreover, in the if you are getting the question for this kind of the algorithm, so you may have given the cost and the heuristic value in your question paper. So don't worry about that one. But in order to write a code, we require the heuristic value and the straight line value. So the heuristic value it is given here, and some straight line value it is being given here. So this is your straight line value. In this value, we have to estimate the cost. So first time we need our we will explore the list for search. The real this search one in priority queue. We have queue here, so we have the priority definition of the base first search function. We are bound the start node, the goal node, and the heuristic value. Thereafter, under first put the cost 0 and put the whatever the starting node we have passed into the prime to the first search, which is being so and so start basically whatever the node A passed that is being done here. Now we are taking the three more function came from means the record of the previous path cost so how much it was costed to reach up to the came from it basically from the starting node and cost so far so cost from the start you are we all the the start node to this so that's why these four functions have been defined here. Now while while the priority queue it is not empty जब तक till the priority empty queue is frontier is not empty we have vision current the current node the current we are getting from the frontier.get function so and the current node. If the current node is your goal node whatever the current node we are finding from the queue we already have put it the uh, first node into the frontier queue. So if it is already visited, if it is already if it so whatever the first node, so what we are getting from the frontier queue, if it is our goal node, then break, and this is the our target. We need to be the next. We look into the graph. Plus from where we have reached, we have reached here. So from added here. If the first if you are the is that one. So and similarly we calculate so far and now the heuristic we already the heuristic value so the heuristic we are adding a new cost with the heuristic value of the new we add the heuristic value and then visit we again started doing same task. Just a new node is being passed to frontier, and then we again go back here to perform the same work till we are not getting the goal node. So what is the goal node? If the current frontier is your goal node, and append the we are appending and showing the path. So this is the code. So and in the last we return the path, which is our target for this particular discussion. So let me execute the code. So in order to execute the code, let me stop this one and let me open the Google Colab. So Google Colab is being start. So so let me share the Google Colab. So here the Google Colab. So now start the Google Colab. Just click on the Google Colab. Google Colab is being start. Google Colab is one of the best platform if you really work with the artificial intelligence, machine learning algorithms using the Python. So Google Colab is one of the best. So now you can see here that we are getting the starting position. And now let me quickly copy the code we have discussed right now. Let me quickly copy the code so that uh, I will show you how the algorithms basically work. So let me copy the code. So put it the entire code. The code we have discussed just right now. We have put it the entire code, and now let me compile this one. So just a compilation is very easy. Compilation is very easy. Just you click on this one. So let me compile this one. And what it will show the output? The path, the entire path. So it is being compiled, and once it will compile, it will return the path from the same we have just discussed here. Just we have discussed the path. We have discussed the path. That path is being returned by our program. The same thing. So you can see that. So this is your best for source. Now I am just for your chat box. You may take it from the chat box. So I'm just posting the code once. It can in the one shot. It cannot accept the entire code. The Google in this chat box will not take the entire code in one code. Just I'm putting the code one by one. And now it is your turn. Now it is your turn to open the Google Colab, take the code, try to compile, and see what is happening here. So, so now the entire code is available in the chat box. You may please take it from the chat box and try to execute the code on your open a Google Colab and try to execute the code. That is we may have a discussion about this. So this is end from my side. Now it's your turn to start the Google Colab and try to execute the code. I'm here. If you're having any issue or any problem or you wish to discuss something, I'm here. You may unmute yourself at any time and we may discuss it. So I am now just muting myself, and now it's your turn to start writing the code on the code.